The following example change of basis is the projection. I will show that actually the projection allows for a nice interpretation in terms of its matrix. Well, consider the following projection on a line L, and it has direction vector minus 2, 1. So here we have a V1 is the direction minus 2, 1, and V2 is the vector 1, 2, which is orthogonal to minus 2, 1. So V1 and V2, they span R2. So instead of the natural basis, now we're going to focus on the basis formed by these two orthogonal vectors. So I have an ordered basis with first element minus 2, 1 and the second element 1, 2. So V1 and V2. So X is mapped according to this projection into T of X. And we know that there's a standard matrix A, but we'll focus on this later. So I can express my any vector x with respect to B, and I can also express any projected vector with respect to B. So I take a matrix with minus 2, 1, 1, 2 with the new basis vectors, and then I know that actually the new coordinates are going back to the standard coordinates. So I have a matrix A and a matrix B. And I know that T of X is a matrix A times X. But now I'll focus first on the matrix B with respect to this new basis. So T of X with respect to B is B times the coordinates of X with respect to beta. So B is actually constructed out of the images of V1 with respect to beta and V2 with respect to beta. And these images are actually easily found, since I know that the projection of V1 onto the line L is V1 itself. So TV1 is actually the coordinates of V1 itself. And V2, since it's orthogonal to V1, is mapped onto the 0 vector. So actually I get a very simple matrix here, the matrix 1, 0, 0, 0. So using this matrix, I may actually calculate A, since I know that this diagram is commutative. I know that actually A equals S times B times S inverse. So it's minus 2, 1. Yeah, so first S minus 1, B and S again. So A equals minus 2, 1, 1, 2 times the simple matrix 1, 0, 0, 0 times the inverse of S, which equals minus 1/5, 2, minus 1, minus 1, 2. And now we may calculate it. 1 over 5, 4 minus 2, 1. Well, you may also check that this is correct using the former theory about projection matrices. So we may take V and project anything on V and calculate the projection matrix directly from it. But here we illustrated that actually we may use it differently by first focusing on the matrix B with respect to an ideal basis with respect to the projection, which is the direction in which we project and its orthogonal part.